without proper electricity lesson, you can't understand electronics and electromagnetism lesson. So that's why it's very important, grade 10 electricity as well as grade 11 electricity. Okay, so 2020 oral paper as well as 2019-18 continuously they ask questions from this electricity lesson. So this is the theory tude I did up to this AC and DC supply, right? So I'll quickly summarize what we had done last week. This is the textbook. Right. So basically home electric circuit and power and energy of the electrical appliances we are going to discuss under this chapter mainly, right? So home electric circuit and power and energy of electrical appliances. So first I'll discuss home electric circuit. After that I'll discuss power and energy of electrical appliances, right? Because home electric circuit, before you use electrical appliances, you should know the basic, you should have basic understanding about home electric circuit, from where you get electricity, how that electricity is produced, what are the energy sources we are using to generate this electricity. Any country, like most of the countries in the world, they are generating electricity mostly using coal power, diesel, or some of the developed countries they are using nuclear power also. In Sri Lanka we don't use nuclear power, we mainly use hydropower and thermal power. In Sri Lanka we mainly use hydropower and thermal power, right? So I will use the PowerPoint slide also the same time. Okay. Last week I told you main electricity supply, the specifications, and from there are two type of current called AC and DC. AC and DC. So AC supply and DC supply. So generators, dynamos produce AC. Generators and dynamos produce DC. And any battery, car battery, motorcycle battery, and solar cells, so they produce DC, direct current. All the batteries produce DC, rechargeable or non-rechargeable, primary cells, secondary cells, all the electrochemical cells including solar panels, DC. And so I told last week the sources of AC and DC supply. Right. You should know the waveform as well as sources and AC. Yeah. So this is the waveform you can see in the next slide. Now the symbol of AC supply and DC supply and the waveform. So it's like a transverse wave. AC1 you can see the right hand side. It's like a transverse wave, right? Transverse wave. And what is AC? So current flows like electrons can flow in both forward and backward alternatively, not continuously, alternatively. Now if you take your water supply and electricity supply, if I compare in your house, water supply, just you don't return that water again to the water board, but electricity is different. There are two, like electrons flows in as well as there must be a path to flow the electrons out. Otherwise what happened, so electrons enter into the domestic or the home electric circuit, that should not get vanish. That's the main reason. But water, you don't return this wastewater, or after using water you don't return that water back to the water board or that pipeline again. So there's only one, only water flows in, but it won't flow backwards. But current, there are two wires. So I'll come to that under home electric circuit. So basically this is what I wanted to remember first. We get electricity supply from power stations, that is AC, and what is the frequency of this AC supply? 50 Hertz and voltage 230. Yes, polarity means like if you mark here the positive and negative half cycles, you can see in this screen. This positive half cycle means current flows forward. Positive means forward. So its negative means backward. Negative means backwards. Minus. If you want, you can take a screenshot of this. Anyway, I have given this in the tutor also. Minus means current flows backward, but is you can see not continuously. Positive half cycle forward, and there's a gap. Gap means what? Negative half cycle backward. So this is the AC waveform. So we get from generators and power. I mean all the dynamos, AC supply. AC supply from in any country, nuclear power or hydropower or thermal power or any power station except solar power, thermal power, nuclear power, hydropower, mainly those nuclear, the most the developed countries, they use nuclear power to generate to rotate the turbine or to operate this generator. They use nuclear power. Some countries they use coal. Even in Sri Lanka, we use mainly coal and diesel other than hydropower. That is the energy source. Diesel, flowing water. Sometimes they use windmill. So whatever the energy source, whether it's windmill or nuclear power or coal power, diesel power, at the end we have to use this. We have to use this AC generator. We have to use this AC generator to generate electricity. So, or in other words, dynamo. So therefore, this is very, very important. You should know from where it is coming and what is the energy source used and what is the nature of current and what is the voltage of the domestic electricity. So if it is like it looks like a transverse wave, then we can introduce a frequency also. This is 50 Hertz. AC means alternating current. Frequency 50 Hertz. That means 50 cycles per second. 50 cycles per second. Then if you take DC means what? It's continuous fixed voltage. Fixed voltage means plus 5, no minus value here. That means continuous flow of current only in one direction. Continuous flow of current only in one direction, but magnitude plus 5 can become plus 10 volt. But the polarity, it won't change. So you don't need to remember everything here, but some of these very important, especially the waveform, because this is linked with electronics lesson also. Now next, let's move on to after the PowerPoint slide. I'll complete the tute. Let's move on to the next slide. Now again you can see the waveform. So this is how we represent the AC and DC supply. So if you put batteries, that is direct current. Batteries, we use direct current. So this is the AC supply, the symbol of AC supply, symbol of alternating current. AC. This is the symbol of DC. DC, or if you want plus and minus sign. That means here current flows always from positive to negative. Current flows from positive to negative. Electric current from positive to negative. Now this AC you can't mark. So it actually this AC supply current flows. So the positive half cycles come from this side and negative half cycles come from the other side. So that means both positive and negative half cycles. So alternatively. That is the difference between these two. You should know the sources of this DC supply, DC voltage. What are the sources? Any battery DC, direct current. Car battery, motorcycle battery, laptop battery, electric vehicle battery, hybrid vehicle battery, pen torch battery, any battery in the world DC. And solar cells DC, sources of DC supply. Please copy down separately in your writing book. Sources of DC supply and AC supply. AC supply, last week also I told, this is important. Generators and dynamos. Mostly they are used in power stations. These are mostly used in power stations. Powerhouses. Hydropower, nuclear power, thermal power, wind power. Any power station, they use these generators or dynamos to generate electricity, that is says. Therefore, in your house, if you take any plug point in your house, what is the nature of current? Or an alternating current. Any plug point in your house, any house in Sri Lanka, if you take the plug point, or the bulbs or the lamp circuits, that is AC. So therefore you should know how to identify the waveform of AC and DC supply and the sources of DC supply and AC supply. In Sri Lanka as well as in the other countries, so you can see this is how it happens. Look at the screen everyone. This is how it happens. Power plants. Power plant can be, now what are the energy sources used? What are the main sources to generate electricity in the world? So one is hydropower. Hydropower. Or else they can use thermal power. Thermal power. Thermal power they can use coal and diesel. And nuclear power. Nuclear power. Remember, they cannot generate electricity to the entire country using a battery. That is not practical. You cannot supply the demand from a battery. That is the vehicles and electrical appliances we use batteries, but practically it's not possible to supply electricity. Right. Therefore, other than these methods, what are the, like, actually at the end we use generators. What we use to generate, they use a turbine generator. Generators are used. What generators? AC generators. In other words, dynamos, large generators. So you have to, there's a turbine. You have to rotate this turbine. Any power station, there's a turbine. To rotate the turbine, you can use wind, kinetic energy of the wind, or you can use flow in water to rotate this turbine. To rotate this turbine, you can use flow in water, or when you in thermal power stations, they boil water and they pass the steam to a Himalaya. They pass steam through this AC generator or the dynamo to rotate the dynamo. That's why during the drought, when the water level in the reservoirs decreases, what happens? Rate of the rotation of this dynamo decrease or the turbine, then power generation also drop. Then they have to supply the demand from the other sources. Then the electricity, the bill, the energy or the cost for the production of electricity increases. So what are the other methods of electricity other than this generator method that is introduced by Michael Faraday? What are the other methods? Any batteries, and the other one, solar cells. These are the three main methods of generating electricity. So to rotate the turbine, you can use hydropower, thermal power, even I can write here wind. So those are the sources to rotate the turbine, wind or geothermal power, whatever this energy source we use, at the end you have to rotate this turbine. At the end you have to rotate this turbine in the power plant or power station. If in the power plant, if they use nuclear energy, we call it nuclear power station. In the power plant, if you use diesel or coal, even plant material, dendro power, then we call it thermal power stations. Thapa viduli balagara, thermal power stations. In the power plant, if you use hydropower, then actually we don't burn any fuel. That is eco-friendly, environmental friendly. We call it hydropower station, flow in water. So this solar cell and hydropower stations, whatever, no environmental pollution, because no harmful gases released to the environment from these two, solar power and hydropower and wind. So those are renewable energy sources, no environmental pollution, no harmful products released to the environment from these. And the others, nuclear power, there's a risk. So nuclear explosions. And thermal power, whatever you burn, coal, diesel, petrol or any other plant material, dendro power, then harmful gases are released to the environment that can cause air pollution, right? Environmental pollution, even some global warming, it can contribute to global warming, and temperature can increase due to the emission of CO2. Battery is the problem. Chemicals and the heavy metals contained in batteries can be released after the lifetime of the battery, after maybe 2-3 years. These batteries we discussed to the environment, then it can pollute the environment by these chemicals. So therefore those are the in the exam, if they give these things and ask you to compare, write down 2 advantages of solar power than thermal power, then you should know what to write. Right. Okay, so Now what, because this diagram is not given in your textbook, but you might not be, once in the oral paper they give a similar diagram and ask questions, right? Some western prize papers also, they can give a line diagram like this, and can ask questions, generator. But generator, no environmental pollution from the generator. Problem is to operate this generator, to rotate this turbine, then you can't rotate this from your hand. To rotate this turbine, then you need some energy source, right? Some energy source, flow in water or something. That is the problem. Whatever the, it depends on the air pollution, depends on the energy source we use. But from the generator or dynamo, no harmful products released. Now let's next part, this transformers. So this is also very important. Near power stations, there are two types of transformers. I told you. Near the power stations, we use step up transformers, that you should know. We use step up transformers, that is transmission done under high voltage. So these transmission lines, transmission done under high voltage, maybe like 33,000 volts, 333,000, very high voltage, under very high voltage. Then that voltage is reduced, to low voltage by in distribution subcenters. They use step down transformers. So what is this transformer? The step down. So therefore number 2 we use step up transformer before transmission. Then again in subcenters, Kalanitis and all this subcenter, they use step down transformer. Then distribution lines. So mostly you might have observed these distribution lines, and again there's a black cable from the electrical post to your house. That is a supply wire. Sometimes here also there's a transformer. You might have seen these transformers. That is also a step down transformer. You might have seen them on the electrical post. Step down transformer. Look at this 1 2 3 4 5, the flow. Step down transformer. So what are there are 3 transformers used, right? Near the power station, 1 transformer, that is step up, and distribution subcenter step down, and near your house step down, because this very high voltage suddenly cannot be reduced to 230. What is the voltage of the domestic house wiring circuit is 230 volt. So this 33,000 or 333,000, so it can be here around say 11,000 or 30,000. So this is 300,000 near the powerhouse. So here it can be around 33,000 volt. Then that should be reduced to 230. That is using again step down transformers. So it's very, very important. First step up near the powerhouse before the transmission. Then in subcenters again step down, and near your house step down. So therefore finally this very high voltage reduced to 230 voltage. Why voltage this very high during the transmission? That is to reduce the wastage. Why transmission is done under high voltage? To reduce wastage of electricity, to reduce the wastage of electrical energy as heat, to minimize heating up of the wires. When you keep the voltage very high, the current will be low here, low current. Less current passes through the wires. When current less, wastage of electrical energy as heat is reduced. Reduces the energy wastage as heat. Right. That means wires get heated up. When you are using any electrical appliance, what happens? Will that ever get cools down? Now your device, whatever the device you use now to join this class, maybe laptop or mobile phone or any other smartphone, when you are using these long hours, what happens? Battery gets heated up. The device gets heated up. That means what? Wastage of energy as heat. So we don't need heat from the device, unnecessarily heating of the device. That also output energy, form of output energy. So if we can if we can operate any device without heating up, then we can conserve energy. We can minimize the wastage of energy. So therefore this happens Now this is long distance from maybe Norachole power plant to Colombo, long distance, maybe 200-300 kilometers. When this current travels longer distance through these high tension wires, what happened? They get overheated and energy is lost in the form of heat. How to minimize this? By keeping the current low and increasing the voltage. Power is not changed. Power, actually there's a power also reduced due to the wastage, but we can minimize that by keeping the current low in the wires. This is very important. If they ask a question in the exam, why transmission done under high voltage, what is the answer? To reduce the wastage of electrical energy as heat, or else to minimize heating up of the wires during transmission. What type of metal is used for this? What type of metal is used for this? Aluminium wires. Aluminium. Why aluminium is used? That is the most abundant metal in the earth crust. Aluminium. Most abundant metal in the earth crust. Aluminium. Aluminium extraction is very important, but we don't extract aluminium in Sri Lanka. We import this aluminium. Not only aluminium, even iron also we import, right? Even vehicles we import. All the metals we import. We don't manufacture any metals in Sri Lanka. That is the main problem. But sometimes what happens, these used metals we can recycle or we remold it, like there are industries, but they import the raw materials most of the times. And so this aluminium not subjected to corrosion. Sometimes you can ask, why can't we use iron cable? Iron is subjected to corrosion and it can react with rainwater, but aluminium has no reaction. It's get converted into permanently into aluminium oxide. And the other benefit, aluminium light in weight and it's very highly malleable. And ductility and malleability is very important when they make these cables. Remember, new syllabus oral paper, the science paper, they raise the question from these practical applications, right? Just by memorizing the textbook you can't answer the questions. Then so that is the transformer, how electricity is reach into a house. Okay, that you should know before you discuss house wiring circuit. Okay. This flow diagram bit important. If you want, you can take a screenshot. Now let's move on to the next part. I'll erase the screen and look at this. Okay, let's move on to the next slide now. Now you can see again same similar one. Power plant generate electricity. Then what is this transformer? Look at here. Why it is called step up transformer? Very easy to remember. Step up means what? Convert low voltage to high voltage. Low voltage is converted into high voltage by this. Then transmission done under high voltage. What is the role of a step up transformer? Low voltage is converted to high voltage. So therefore step up transformers are used in mostly in what? Near power stations. Near power stations we use step up transformer to convert low voltage to high voltage. I am repeatedly telling this. This is linked with electronics and electromagnetism lesson. If you don't do this lesson properly, you will find the electromagnetism and electronics lesson very hard. Remember the next three lessons. Don't miss any class. Next three lessons, most difficult lessons in your syllabus. What are the next three lessons after this one? Electronics chapter 11. Chapter 11 electronics. Right? Chapter 12 electrochemistry. And chapter 13 electromagnetism lesson. All these electro. Now also we are doing electricity. Electromagnetism. 3 hardest lessons in your oral syllabus. Electronics, electrochemistry and electromagnetism. Now also we are doing electricity. If you don't get proper understanding this, if you don't get this concept, the electricity, then now under the next 3 lessons will be hard. Okay, then I told these transmission lines or high tension wires, cables. So they are made of aluminium and transmission done under high voltage because to reduce the heating up of wires. And then after that distribution sub-center. So you can see I'll highlight this step down transformer. If you want, you can take a screenshot of this. This is step down transformer. And what is the role of step down transformer? That high voltage is again reduced to low voltage. High voltage is reduced to low voltage. And then again this low voltage, now it's not 230 yet. Therefore now your house is 230 volt. Then again near this also there's a transformer. What is the other? That also step down transformer. This is very, very important because you easy whatever you read text you will forget easily, but the diagrams, pictures, animations, videos you will remember better. So that's why I'm using before the theoretic this flow diagram. You will remember this easily, but in the exam also they can give a similar line diagram like this, and they can ask X, Y, Z. They'll put key boxes here, 3 boxes X, Y, Z. They'll ask what it is. They'll give X, Y, Z, and they'll ask what is the transformer used and what is the reason. They can keep here X, Y, Z, 3 boxes, and can ask what is the type of transformer used in each and the role of that transformer. Okay, that is how you get electricity to your house. Okay, I'll erase this now. Next one. Next one, you can see these high tension wires again. High tension wires, can you remember these wires? Again, you have to recall your heat lesson. These wires must be loosely fitted. If they are tightened, what happen? Daytime they expand. Daytime these wires expand. Daytime they get heated up, and that is thermal expansion. If they can't expand, then what happen? They get disconnected from these places. That is very dangerous. Thermal expansion, because they are metal. That also should come to your head when I teach this. So they are loosely fitted so that electricity, daytime, it allows daytime to expand them. Otherwise, if they are tightly fitted between electrical poles, what happen? No room to expand. Then they will get disconnected from the electrical post. Okay, then next part. I told the metal used for this also I told. Again, you can see this is a subcenter. Can you see the screen? So this is distribution subcenter. Sometimes you might have seen this somewhere in Palagoda, Kalnithis. So there are some subcenters. So they reduce the voltage from high value to low value using these subcenters. There are transformers. So all these metals, transformers, the internal structure of the transformer we will be discussing under chapter 13 electromagnetism lesson. Chapter 13 electromagnetism lesson. Then next one. Again, you can see these high tension wires may be very high voltage. Back to the previous one again. So okay, can you see there's a transformer attached to the electrical post here? So they don't allow construction near these high tension wires, because very high voltage, when the voltage increases, when the voltage become more than 100,000 volts, so the current, there's a risk. So therefore they don't allow the apartment, like you have to be very careful near these high tension wires. There can be a spark from these wires during lightning, or even when the voltage, when the pressure changes occur in the atmosphere, there can be a spark. Therefore it's dangerous. Sometimes the kids now, the small ones, they fly kites, so then they even the tall trees the branches of the trees can contact with these high tension wires. So if you are climbing the tree, then what happen? You can get electrocuted. So it's very dangerous. So this is a transformer. This will be a step down transformer. Down transformer. Sometimes you might have seen this, but you are not, you don't, you might see this, but you don't pay attention. We don't care what type of transformer is this, because anyway, so you just see them, but very few observe this. Step down transformer. That is to reduce this high voltage. Maybe this line 33,000 volts. Now you have to reduce this to these wires to maybe 11,000 volts. So that is by step down transformer. Right. Okay, then next one. Right. Again, you can see there's a transformer. Definitely you might have seen these transformers in your area when you're traveling along in the road. So you might have seen these transformers, right? Okay. Again, there's a transformer here. Right. Now, transformers, not only in this house wiring circuit, you can see here also there's a voltage reduction. Can you see the screen? Now, definitely you might have all of y'all, now these days everyone using devices, right? You know, electrical, I mean laptops and mobile phones, the smartphones. So all are using. Now, can you see here the input voltage? Please look at the input voltage. What is the input voltage? 100 to 24. Now this is the range because they are exporting these laptop chargers to other countries also, not only to Sri Lanka. Then they keep the range, input range. So in Sri Lanka it is 230. What is the voltage of any plug point in a house? 230. But you can see the laptop battery, the voltage, the other end laptop battery voltage, you can see 19.5. This is the laptop battery. Unfortunately, they haven't given this type of diagram in your textbook. But if they give these diagrams, it's very easy to teach this. Laptop battery, the voltage. What is 19.5? So this is the input. Input plug point, it's 230. Plug point voltage 230. Input. And output, you can see laptop battery, it is 19.5 volts. You can check if you have a laptop charger, you can definitely observe this in there's a label here, right? There are so many things mentioned here. And what is this name of this call? We call it laptop charger. Actually this is box like thing, otherwise we don't need a box like this. We can directly connect this cable to the one end to the plug point and the other end to the laptop battery. Then the battery will blast, right? It will definitely get damaged because battery can be charged only using 19.5. If you supply more than that, the battery get damaged. 19.5. Therefore you can see now there's a voltage reduction, right? There's a voltage reduction. So this is to the this end, what you get, 19.5 volt, that is to the laptop battery voltage, and the other end is not connected here. From the other end there's a wire that is to plug point, that is 230 volt. Now you can see there's a voltage reduction by this. That means what? Inside this box there's transformer action is there. That means what? This box like thing of the laptop charger convert high voltage to low voltage. Again I am repeating this. It converts high voltage. What is the high voltage? Input voltage from the plug point 230 and output voltage 19.5. It is not, it's given here on the label, right? Charger. And why it is called AC-DC adapter, right? See, he is very interesting. Why it is called AC-DC adapter? It converts not only the voltage reduction, it converts AC to DC. What is the input voltage from this plug point? It is 230 volt. Actually I am telling this because you will not learn this in the textbook. They have given laptop charger, but without the laptop charger in the textbook they'll teach in electromagnetism lesson, electronic lesson, and this concept is linked with 3 lessons: electricity lesson, electronics, and electromagnetism lesson. Electromagnetism lesson, transformers. Electricity lesson, domestic circuit, is plug point sockets 230 volt and AC-DC thing. And this AC-DC adapter, that actually there's an electronic circuit inside. So that electronic circuit you will learn in grade 11, chapter 11 electronic lesson. That's why I told if you miss one lesson, then you will find very difficult to understand the exercise. So this is 230 volt. You connect this to the plug point and it is voltage reduction. That is why it's a small transformer action is there inside this box, plus AC to DC. This 230 volt, the plug point, that is AC supply. So it convert AC to DC, any battery direct current. You cannot directly charge any battery from directly from AC supply. From AC supply you cannot charge the battery. That means what? To charge the battery you have to convert AC to DC. That is why the name of this called what? AC-DC adapter. But we never call in our day-to-day life, where's my AC DC adapter? You ask, where's my mobile phone charger? Where's my laptop charger? Actually, scientific name is what? AC DC adapter. Or sometimes we call it power pack also sometimes, but mostly we call it AC DC adapter. And so what are the two functions of this? One main function of this is what? To convert high voltage to low voltage. Second function, to convert AC to DC. Everyone is using this, but most of them, very few knows what is the role of this box. So if you cut this box and directly can you connect the wires? If you remove this box and one end of the wire you connect to the laptop charger, this end, and the other end you directly connect to the plug point, will that work? No, right? So definitely the power system get damaged in your laptop. Right. Then so that is the actually all these applications very interesting. I mean the grade 11 it's hard but interesting, more applications. Grade 10 mostly theory concept, but here there is a lot of applications. Right, again you can see again laptop charger given here, output 19 volt. So most of the laptops is around 18 to 20 volts. But if you take mobile phone battery, is less than that. Voltage of the mobile phone battery not 19, is around 4 to 6 volts, say 3.5 to 6. And here again you can see a mobile phone, now that is 5 volt. That is the mobile phone battery. So this end, this is to charge the mobile phone battery. So that is the voltage of the mobile phone battery. But from the other end you get what? 230 supply mobile phone battery. You have to charge from what supply? 5 volt DC supply. From this end you should get the DC supply, direct current. But the other end you should get, this is DC and its battery is direct current and voltage of the battery 5 volt. But this end you can see it is what is the voltage from this end when you connect this to the plug point? That is 230. So you have to connect the other end to the plug point, that is 230. This is 230 volt. So again here what is the role? Again this is called AC-DC adapter. This mobile phone charger also called AC-DC adapter because it convert plug point AC, mobile phone battery DC, and plug point 230, mobile phone battery 5 volts. So therefore voltage reduction and AC to DC. What are the two major functions of this, whether it's laptop charger or mobile phone charger? Convert AC to DC and voltage from 230 volts to 5 volts in case of mobile phone battery, in case of laptops around 19.5. So that is the role of this box. You can see, otherwise they don't need to waste energy. I mean the more energy, more materials, more raw materials consumed for this plastic, this casing, so this box. So so most of the people, they don't know what is this box, right? What is happening inside this box? They have given here. Can you see the input voltage here? 230, and output here they have given 5 volts here, 5 volt 2 amperes they have given here. So always my advice, before you use electrical appliances, use to read the label. Don't ask from the others. You look at the instructions given in the manual or the catalog or whatever the instruction manual, you have to refer before you ask from the others. That is more reliable than getting the other opinions. Because mostly we are not used to read the label. When you go to buy any other food item, we don't look at the label even. We check only the brand name, price and everything, but we don't check the ingredients of this. That is very important. So it's applicable to this also. And the other thing, I'll come to that under power. The other most important you should check. Okay. Next one. Again, you can see this is transformers. I told you this is not transformers, sorry, generators. Generators generate what? AC supply. It is AC. This is generators used in power stations. Generators are used in what? Power stations means nuclear power station, thermal power station, hydro power station. Any power station, you need the generator because we use this energy source to rotate the generator. I mean the turbine of the generator attached to the generator. The next one, again I have given this huge generator in nuclear power stations. They use large generator. So to rotate this, what you need? A lot of energy. So they use nuclear energy to rotate this. If you don't rotate it, what? No power generation. Then so this is the most simplest version of that bicycle dynamo. So bicycle dynamo, when you ride the bicycle, this wheel or the metal wheel or the cap gets rotated. When this rotates, there's a magnet inside. This magnet also rotate. When magnet, around the magnet there's a coil. Don't worry, we are discussing this under electromagnetism lesson chapter 13. Then this generate electricity. When you're riding the bicycle at night, then you get light from this. So are there any chemicals or the harmful gases released from this? No. Eco-friendly, environmental friendly. There's no battery, there's no chemicals inside. The same concept. Now here we rotate this wheel, the metal wheel, using the bicycle tire. When you ride the bicycle fast, what happens? This also the rate of rotation increase, then the brightness of the lamp increase. But if you are just pushing the bicycle, then what happens? No, you cannot light up the lamp. Voltage is not enough, energy not enough. That's the one disadvantage. At night, when you're riding the bicycle fast, brightness increase when you increase the speed of the bicycle. And for the same concept, they use in power station also, whether it's wind power, hydropower, wind power, thermal power, nuclear power. So they use that energy to rotate that turbine, even hydropower station. Okay, then again you can see the other methods of generating electricity, batteries. So batteries, there are different type of batteries, right? So the batteries also used to so this is some are rechargeable batteries, some are non-rechargeable, and there's a pentorch batteries. All these batteries, what? Sources of DC supply. All these are sources of direct current, DC supply. That's very important. And next one, again laptop battery. So I told you earlier, around the voltage of laptop battery around 19.5. This is also DC, direct current. Therefore you have to recharge the battery from direct current. But plug point you get from the any generator, any dynamo produce AC. Then you have to convert AC to DC before you recharge the battery. The main problem is the chemicals. So the battery comes from chemistry, right? Again, this mobile phone battery, that is again sources of DC supply, sources of DC, any battery direct current. Now you can see this battery, what? Lithium ion battery. Can you see here? Lithium ion battery, what is the voltage? 3.8 volt. That's why you should not use the others mobile phone chargers. What happened? From mobile phone charger to mobile phone charger, the output voltage different. Now this battery 3.8. So you use your elder brothers or the elder sisters charger, so it release 4.5, because they are that one mobile phone battery different. Now you are supplying 4.5. Then what happened? Lifetime of the battery decrease. You will not be able to use this battery for a longer period. So you will have to definitely replace the battery. Don't use the wrong charger, because when you change the charger, the output voltage will change. Right? So output voltage, so mobile phone to mobile phone, the battery voltage slightly changed. So therefore that's why you should use the original charger of that. The battery lifetime definitely will decrease. So all this are related with your, and again this car battery, what is the voltage of the car battery? 12 volt, that is also DC. So this is rechargeable one, that is also DC supply. But the main problem, after about 3-4 years, most of these batteries you have to discard. So then those chemicals are released to the environment. Now number of mobile phone batteries in the world in Sri Lanka more than the population. Right? Number of mobile phone batteries in the world more than in Sri Lanka even more than the population. Therefore after every 2-3 years more than 20 millions of batteries released to the environment. It will deposit with these chemicals to the soil. This is what? Hybrid vehicle battery. That is also DC. So now the batteries, this research and development on batteries very, very important. One of the most very demanding area in automobiles. Right? Okay. So this is what this is again direct current. What is electric vehicle, EV battery, electric vehicle battery. So again, when you are charging if you are charging electric vehicle, so the plug point, so 15 ampere plug point we are using, that is AC. Then electric vehicle charger also, there's a box like thing in the middle, that is to convert this electric vehicle, the battery, this is direct DC. So but the plug point AC, then you have to convert AC to DC before you charge the electric vehicle battery. So those things are very important now, because we are using this. It's applicable to not only for the exam, it is very important in our day-to-day life. Right. again you can see this one is very important. What is this? I think mostly we call it power bank, right? Power bank, is there a box like thing in the middle? Is there a box like thing in the middle? No. Why? Because this also DC, power bank also DC, your mobile phone battery also DC to DC. So then you have to use the right one. So then it's no problem. You don't need to convert AC to DC. But when you are charging this power bank, then that matters. When you are charging this power bank from the plug point or the socket, so then you have to convert again AC to DC. But when you connect this to the mobile phone battery, no problem. Power bank also, there's a battery inside, that is any battery DC, mobile phone battery also DC, then no need to convert AC to DC. Right? So those things very important. Then next one. If you take solar cells, right? Solar panels, that is the other environmental friendly one, that is also what? Direct current, all the solar panels, direct current. Then the next problem is what? When you convert the solar panels, daytime generate electricity, this electricity you have to convert, because inside the house is AC, more fan, AC, or most of bulbs and all these lamps, fan, AC, most of the devices. So operated from AC supply, rice cooker, blender, grinder, washing machine, all these lamps, all these electrical devices, electrical appliances operated from AC supply. Unless it is a laptop charger, mobile phone charger. If there's a rechargeable battery, then definitely you need a AC-DC adapter. If there's a rechargeable battery in it, you need a AC-DC adapter. Otherwise, you can directly connect the AC supply without. But when you are installing solar panels, there's an inverter. This inverter, one role is what? To convert DC to AC. So when you export that to the national grid, also you have to convert it to AC. So this is very environmental friendly. No gases coming out, no harmful gases, no smoke, no harmful gases. Therefore, this is eco-friendly, and no chemicals used. You can long lifetime, about 25 years you can use, and solar energy freely available, no electricity bill. If you install this much of solar panels to your roof, you can make your entire house air conditioned 24 hours. The initial cost will be a bit high. You can, if you install at least about 16 panels, about 10 to 16 panels, then you can make your electricity bill zero lifetime, and but it costs about 1 to 2 million, right? About 1.5 million, that around 15 lakhs. If you are getting electricity bill 2,000, 3,000, then no point of installing solar panels. If you have a plan to make your entire house air conditioned, then you can install solar panels and you can make the electricity bill zero. Or else the best thing is you can install solar panels and you can export that to the national grid electricity board. You can export this and you can get money for that. That is the other alternative solution if your consumption is. Or else you can utilize the amount you want, and for the rest they will pay for you. That means the electricity board will pay for this. So there's a net metering system for that. And there are three systems: net plus, net metering, and net accounting. If you are interested, you can check with the internet those things. Right, then so that is very important. Again, solar panels also, they are in electronic lesson, that's why. So this is what we are going to discuss today now. I told you from where you are getting electricity, what are the sources and what are the devices in between. Before we discuss the domestic electric circuit or house wiring circuit, these things very, very important. Now up to here I explain. Until this I explain. That means near this until this electrical post, I told you what is happening. Now remember, as I explained, there are two cables. What is this black one? This is called neutral wire. And this red one is called live wire, or the phase. This is the live wire. This red one is the live wire L, and black cable will be the neutral. Why this live and neutral, two wires? So but in the water supply we don't use two connections, we use only one line, water supply. There are no two pipelines in and out. But here live means current flows in. That means current flows in. That means high, and after releasing that, then it flows into your house, the other way around, no? From the electrical post, so this power in. and then after releasing that energy the electrons return. So actually current means flow of electrons. You have learned that in grade 10 electricity. Current means the flow of charges, rate of the flow of charges. That means what is the charge particle? Electrons. So high energy electrons reaching in, and then after releasing that energy then they should return and get that energy back and come to this. Therefore both live wire and neutral wire passes through the electric meter. So therefore without electricity meter you cannot get the electricity supply to your house. This is a property of the electricity board. You have to pay for that. So you cannot buy from the electrical shop or in the market this meter. This meter you have to get from the LECO, that means Lanka. There are two institutes you can in our country which distribute electricity. One is LECO and the other one is CEB, Ceylon Electricity Board, and LECO, that is a private one, semi-government one. So these two, so that is the property of them. So you cannot repair this. You can't get an electrician and repair this. So any fault you have to report to the electricity board, LECO or CEB. So this one not for any safety. This is to calculate the electricity bill. This is used to calculate the electricity bill, right? So at the end of the month they can check the number of units consumed in the house. So that is measured in kilowatt hours. Electricity consumption measured in what? Kilowatt hours. K simple, W capital and H simple. I think I shared with you a video, Guru Gedra program. I did discuss a revision paper there. I don't know how many of you watch. I shared that with your paper class WhatsApp group. The first question I discussed in that revision paper in that video, it's available in the YouTube. So that is main unit of the electricity consumption, that is in kilowatt hours. W capital, K simple, kilo, K simple, W capital, H simple. Be careful, MCQs they can ask the unit of the electricity consumption or unit of measuring electrical energy, kilowatt hours. Kilowatt hours. Next one. I'll erase this. After that, one more component is there. It's not shown in this diagram. I'll come to that. Before that, there must be a fuse here. Actually, that fuse is not mentioned here. That is for overload circuit breaker. After that, there's a, I think that should be the fuse here. Yeah, that is a overload circuit breaker has to be there, but it's not mentioned here. Then you get a trip here, the trip and the main switch, right? I'll come to that after this. I'll explain that in the next diagram. Distribution box, I'll come to this slide later because we have to complete the tute also at the same time. Again, you can see, this is the fuse. Okay, this diagram you can see it. This diagram you can see it. Okay, what is this? If you want now, you can't see this daytime. Tomorrow morning, you can see this in your house definitely from the electrical post. From the electrical post, there's a cable connected to your house. That is the called supply wire, or we call it service cable. What is called supply wire? Supply wire, sometimes we call it service cable, service wire, supply wire, service wire. So this inside this black cable there are two wires. One is the live wire and the other one is red one is the live wire. That is the standard symbol we use for the live wire. Live wire is dangerous because current is always available in that wire, and the other one is neutral wire. That's why I told you that is the difference between the water supply and electricity supply. Water supply and electricity supply. Water supply only in, water is not flowing out in the same, or there's no separate line for that. After utilizing water, you should have a wastewater pit in your house, in your garden. Wastewater pit or toilet pit to discharge that water from the sink or the bathroom tap line. But we don't release that back. But here there are two lines. So current flows in through the live wire and return through the neutral wire. Live wire, current flows in, electron flows in. After releasing that energy of the electron, high energy electron, so the low energy electron again return that. That is a neutral wire. So that's why that is the one difference between water supply and electricity supply, because any house now in Sri Lanka you are paying for water that you are drinking and you are paying for the electricity. That means you get electricity bill and water bill. Okay, then this is again very important. Everything that you download from the internet not 100% correct. So that is this capital K is wrong. So kilowatt hour is correct, but this should be simple K here, right? single phase. And there are like single phase electricity, single phase also there, we call it actually they don't ask this in your syllabus in detail, but 3 phase and single phase there, right? Tekala saha. Yeah. Then after that you can see here, okay, number 1 I'll label here. From this, no need to study again the textbook or the theory. If you can remember here itself, if you can remember this, no need to waste time again. You will definitely remember all what I am explaining, then you can easily answer any question. We'll be completing the theory also that text you will forget. No, these things you will easily remember. What is this fuse? That is called overload circuit breaker. What is this fuse called? Overload circuit breaker. Overload, that means when the load become more than, what is the ampere value here? Around 30 amperes, around 30 amperes current. So if the current exceeds than 30 amperes from the live wire, then this overload circuit breaker will break down and disconnect the supply. Disconnect the supply. What is this called? Overload circuit breaker. Or sometimes in old houses we call it service fuse. This is mostly near the electric meter. What is this called? Service fuse. See whether the service fuse or the old houses we call it service fuse. There's a thin fuse wire. Now modern houses we call it overload circuit breaker, because service fuse you have to replace it manually, but overload circuit breaker automatic one. Overload circuit breaker. What is the, from the word itself we can remember the meaning. What is the meaning of overload circuit breaker? If the current, the load go beyond the limit, all the electrical appliances connected to the plug point can get damaged. Then it provides a safety for the consumers as well as electrical appliances. Overload circuit breaker. Overload circuit breaker. Right. Then after that, electric meter, that is not for the safety, that is to calculate the electricity bill, and that is a property of the electricity board. And the other most important thing, you can see through the service fuse. If you want, you can copy down this in your short notebook. Only live wire pass through the overload circuit breaker. Again I am repeating, only live wire pass through the overload circuit breaker, but through the electric meter both live and neutral. That is one difference. After that, can you see it is printed here? What is this called? Isolator. In our daily life we use the that is actually the real name, isolator, but in our daily life we call this main switch. What is this called? Main switch. So what is the role of the main switch? Imagine if someone get electrocuted in your house, you have to immediately disconnect the supply from this. See whether I don't know how many of you know the where the main switch in your house. So if no, everyone in the house, you should know where the main switch is, or the isolator. Common name main switch. We call it isolator, right? So I'll label now what are the most important one before you get electricity supply. Number 1, overload circuit breaker. Then number 2, electric meter. Then number 3, what? Main switch or the isolator. So what is the role of main switch? Whenever necessary, when you are doing an electrical repair, or if someone get electrocuted, or in case of emergency electric fire, you can manually off this. You can off this. Can on and off manually. Right? Can on and off manually when necessary. Overload circuit breaker, if the load, if from the national grid, if the load go beyond the limit, then it will disconnect the supply, protecting the devices in your house. Then the other one, can you see, this is called RCCB. I think you can see the name also, RCCB. Actually in physical class I bring all these devices, components into the class and show the students, but unfortunately, so here you have to, it's not hard, you can remember this easily. So what is called RCCB means that is the fourth one. Number 4, that is called the trip. That is called the trip switch. Right? Trip. So what is the fourth one? Trip switch. Main switch. After the main switch, you have to remember this order. They can ask this in the exam. They will not give this entire diagram as it is the real appearance in the exam, because then you can easily remember what it is. From the diagram you can, from the image you can easily label. So in the exam they will not give this real appearance or the colorful diagrams. You get block diagram, or they'll give few cages, X, Y, Z, or A, B, C, D, and then they'll ask write down the order of connecting these components and write down the main function of each component. That's how they will ask in the exam. That is given in the teacher's guide also. So again I'll repeat, what is the first one? Overload circuit breaker. And overload circuit breaker, what the rated ampere value? Around 30 amperes. There can be a range, because every time this will go off slightly, the current can fluctuate in the house. So current can slightly change, therefore they'll give a range here, 30 to 40, or like maximum 40, below so but average value 30. So that is the overload circuit breaker or fuse. But actually here it's given service fuse, the diagram, not the overload circuit breaker, but now we use overload circuit breaker. Second component is what? Electric meter. What is the role of electric meter? To measure the electricity consumption in the house, or energy consumption, electricity consumption, unit of measuring electricity, that is kilowatt hours. So that is a property of the electricity board, electric meter. After electric meter, what is the next component? Main switch. What is the other term used for the main switch? Isolator. What is the role of isolator? To disconnect the supply when necessary. In case of emergency electrical repair, in case of electrical fire, whenever necessary you can off it. When someone get electrocuted, you should not wait until the trip is working. Some of the houses trip is not working, RCCB automatically go off. So this trip, sometimes during lightning, this go off, then you have to on it manually. But sometimes when someone get electrocuted, whenever there's a leakage of electricity from your house, from the main circuit, the trip go off. But some houses the trip is not working. Then what happens? The person will die, because continuously the leakage current can pass to the consumer, to the earth, to the house, to the ground. Then you get electrocuted definitely and will die. Then if you observe someone getting electrocuted, don't pull that person, don't touch. First thing you should do, you have to disconnect the supply from the main switch. You have to disconnect the supply from the main switch. So therefore all this for the safety. Without this, the electricity board will not give the connection to your house. After the construction, after house wiring done, you have to inform the electricity board, now give us the supply. Then they'll come and check whether all these components are connected properly. Otherwise they will not give the supply, right? The electricity board. Then next one, we call it distribution box. What is this called? Distribution box. I'll put a box around this part. So there are a lot of fuses here. This is called distribution box, fuse box. This contain MCB or fuse box, or we call it distribution box. So this distribute electricity to the branch circuits, maybe the kitchen, or kitchen and whatever the area, various parts of your house, dining room, like maybe different parts. So that disconnect. Imagine now this is to the kitchen in your house, right? This first fuse. If you off this part, no electricity supply, only to the kitchen. Right? So this is dining area, this fuse. So all the fans, AC and lamps, all dining area. Then if you off this, only that area, no, the power is interrupted. That means no power supply. Right? So you can manually, if you're doing an electrical repair in the kitchen, no need to off from the main. If you want, you can easily off only from this. Otherwise, in the dark at night, if you are doing the repair, then the entire house is in the dark. So everyone has to stay in the dark. So then you can overcome that problem if you disconnect the supply from this fuse. So if you are using more than the required amount, each fuse there's an ampere value. So imagine this is 6 ampere value. So imagine this is 10 ampere value. So if you are exceeding that ampere value, then also this will go off. If you are exceeding that ampere value, so imagine kitchen, all the plug points and everything, only 6 amperes. Now you connect so many plug points and trying to get more than 6 amperes. Then this will not allow that. Understood? So that is why it controls the amount of current that flows to each branch. That is also for the safety. So what is called? Distribution box, or we call it fuse box, distribution box, or we call it somewhere D box, D board, distribution board. Some houses we call it D board. Sometimes we call it fuse box. So copy down all the terms. And sometimes we call it distribution box. This entire thing, everything together, actually most of the houses, so we call it consumer unit. This 2 3 4 5, I'll put here number 5 for the last one, number 5. Now actually now the lesson is almost done with this the PowerPoint slide, then we can complete the note quickly. So this entire thing is known as what? This entire thing is known as consumer unit. 3, 4, 5, everything together called what? Consumer unit. Consumer unit, right? So this is how the components are connected in the house wire and circuit. Okay, I'll erase this. Anyway, we are doing that in the tute also again, because then you will not forget this second time when you're doing in the tute. Right. Then next one. Again, this black cable here. This is how you will observe most of the houses now. If you some houses, this is that service fuse, the fuse box. Service fuse. Sometimes we call it overload circuit breaker. Overload circuit breaker. After now tomorrow morning, check all these are there in your house, and ask from your parents or someone whether where's the main fuse, where's the trip switch, where's the main switch, where's the main fuse, and this is the electric meter, right? Okay, that you know, or this is the cable connected, right? Otherwise, if you don't know where's the main switch, what happened when someone get electrocuted? If the trip is not working, then you are running here and there to find the main switch, then that person will die. That person will definitely die when you find the main switch. Therefore, every member, right, in the house, everyone in the house should know where the main switch is, because in case of emergency electric fire, when someone get electrocuted, you have to disconnect the supply from the main. Right? Again, this one, the electric meter, they have nicely given the correct unit. What is this called? Kilowatt hours. So actually, what is kilowatt hour? Kilowatt hour means the watt value divided by 1000. How to convert watt into kilowatt? If you divide the watt value by 1000, then it become kilowatt. So the watt value converted into kilowatt by dividing 1000. If you multiply this by number of hours, then you get kilowatt hours. So that's how it happens. If you can copy down in your short notebook, watt value divided by 1000 become kilowatt. Then kilowatt multiplied by number of hours, then it become kilowatt hours. That is the meaning of kilowatt hours. Watt to kilowatt, and kilowatt to number of hours multiplied by number of hours, then it becomes kilowatt hours. KWH. Now one of the best example, imagine I use 2000 watt. Normally you can check in your house where electric kettle, what is the watt value, right? What is the watt value? So imagine 2000 watt. So you use this electric kettle 2 hours per day. Now I want to find per day what is the electricity consumption by the electric kettle. How to do this now? How to find the number of units consumed? 2000 watt divided by 1000. Why divide by 1000? To convert watt into kilowatt. Multiplied by 2 hours. Very easy. Then how many units by the kettle, due to the usage of the kettle, how many units consumed in the house? 2000 divided by 1000, 2 kilowatt multiplied by 2 hours. Then you get what? 4 kWh, 4 kilowatt hours. If 1 unit costs 10 rupees per day, you have to pay 40 rupees for the usage of the electric kettle. You understand what I'm saying? So you will get similar calculation in the exam. Again, I'll repeat that. Try to remember everything. Don't ever expect I will read the note and later I'll study this and you are doing engaging in something else while listening to this learn. So pay 100% attention to this. Don't engage with any other work while you are doing this 2 hours per week. 2 hours per week, only 2 hours per week. So that one you need 100. I need you to 100% attention here. Otherwise, you will not remember this well. Otherwise, you have to waste time again on this to study this, to recall this. So what did I tell now? 100 watt electric kettle. If you are using 2 hours, how to find the number of units? That's what I explained. 1000 watt divided by 1000. I put 2000. Okay, 2000 watt. 2000 watt kettle. How to convert into kilowatt? Divided by 1000. Then you get here 2 kilowatt. Now multiplied by 2 hours. Then you get what? 2 kilowatt hours. That's it. That is this much of units. If 1 unit cost 10 rupees, then you have to pay this is 4 kilowatt hours. 2 into 2, 4 kilowatt hours. So then with 40 rupees, number of units consumed 40 rupees. Now at the end of the month, sometimes they can ask one recent past papers also, they ask at the end of the month, then 30 days. Assume 1 month, 30 days per month, how many units due to the usage of this electric kettle? So any device you can calculate the electricity bill like this. Then what happened? three zeros cancel, then it's become 2 kilowatt multiplied by 2 hours, that means all to the 60 hours. So 60 hours, then how many units for the usage of the electric kettle? 120 kilowatt hours. 120 kilowatt hours. 120. If one unit costs 10 rupees, then 1200 only for the usage of kettle in the month at the end of the month. But I don't think you are using 2 hours to boil water in the kettle, maybe like 2-3 minutes, but I told like 2 hours. So you boil in the morning, again 12 o'clock, again in the evening, about 4-5 times if you are using them, then per day it can be 2 hours. This is how they ask questions. This is very important. This is very important, how to calculate the number of units. Kilowatt hours, when you write the final answer, don't forget the unit. And even though you write unit, if you write the wrong unit, then also no marks. Capital K, no marks for the final answer. Capital K is Kelvin, then become Kelvin watt, not kilowatt. Right? Understood? Sometimes they can give in seconds, 30 seconds. Then you have to convert it to hours. 30 seconds. How to convert seconds into hours? Divided by 3600. If they give the duration in seconds, how to convert seconds into hours? Divided by 3600. Then you can convert that into hours. So please copy down that if you don't know how to convert seconds to hours divided by 3006. Then how to convert minutes to hours, that is divided by 60. Then seconds to minutes, again divided by 60. That's why 60 into 60, 3600. Seconds to minutes 60, again minutes to hours 60. So that time unit conversion you should know the time, right? Okay, so that is about this electric meter. That's very important, right? Then next one, so the calculation you can get, I have given this equation in the tutor also. After this we can quickly finish that. Then next one, okay, we'll complete after that. I'll come to the other rest, right? I'll complete this PowerPoint. I have explained up to this. We'll copy down now. Up to this we'll copy down the theory tune. Okay, back turn everyone. Please raise the hand those who have got a hard copy of this theory tune. Chapter 10. Last week I posted this about 1 week back. I posted this to a WhatsApp group, right? PDF of this tune. Please raise the hand those who have got the printout. Those who have the printout or the hard copy with you now. Then you can complete the blanks on the tune itself. If not, no problem. Don't be in a hurry. Because of this pandemic situation, you have to be careful. You have to copy down only the blanks, the answers on a separate paper. I mean, CR book, not on a paper. CR book. Otherwise, you will misplace the papers also. On a CR book, you copy down electricity lesson, chapter 10, grade 11. Write the topic and write the page number, and this each part you have to write the answer. Later, you can take a printout and complete the note. Okay, this is where we stopped last week. Okay, look at this. I have given number 5. What wires that consist in the supply wire, or can you write here supply wire or service cable? Please highlight service wire or supply wire. Sometimes we call it service cable. From number 5 onwards, we have to start today. This is the national grid. Actually, this capital A, the national grid. Can you see here blue and the red? Actually, mostly it's black and red or blue and red. Live and the neutral wire. This capital B will be the supply wire. This is the distribution cable. This capital A will be distribution cable. This supply wire consists 2 wires. That black cable connected from the electrical post to your house. The black cable consists of 2 wires. What are the 2 wires? Live wire. Come to the first blank, not capital A. Live wire and neutral. Live wire within brackets, right? Capital L, comma, neutral wire N. There's a standard color also for that, neutral wire, capital N. Live and neutral. So this is, if you want, you can put an arrow here, label, this is the live wire. So this is the live wire, and here the neutral wire. Can you see here the live and the neutral? Live wire and the neutral wire here. So if you get 3 phase, then earth wire. What is the other one? Earth wire, right? So earth wire is not included in the supply cable. So capital A, actually the distribution wires, and capital B will be the service wire or the supply wire. So right here, distribution wires or the cables, and capital B will be supply cable. or service wire. So this supply cable consists of what? Two wire. There's a black cable. Definitely tomorrow morning you can see between the electrical post and your house there's a black cable. This black cable consists two wires, live wire and the neutral wire. Live means what? Current flows in high energy electrons, and black means those electrons are returning after giving you energy. Then C will be, can you see in the PowerPoint also I told you what is C here? That is the overload circuit breaker. What is called? Overload circuit breaker. Overload circuit breaker. Overload circuit breaker. That is also called service fuse. Service fuse of service fuse. Overload circuit breaker, modern house, so we call it sometimes service fuse. Then we will be discussing one in detail, don't worry. This capital D will be what? Electric meter. Capital D will be electric meter. Electric meter. Electric meter. So sometimes in the exam they can give a line diagram like this and they will ask you to label this, right? Okay. Now electric meter mostly outside of your house. You can't install inside the house this electric meter, but otherwise that person will come inside your house. Then to get the reading, then you are in trouble. Then if that person is infected with COVID-19 virus, then coronavirus, then that will be a problem. So then even your house is closed, the door is closed. If they can, sometimes some houses they keep this in the wall, like they make a small place in your wall outside. Then no need to enter into your premises. Even they can from outside on the road, so they can view this reading when they construct the house. Now they use it because even if you're out at home, then there's no one to open the gate, then they can get the reading from outside. Otherwise, if you are not every month, if you are not staying at home to open this gate, then they'll go estimated bill. That means last maybe 6-7 months they will check the average and they will give an estimated bill until they check the reading. So sometimes if you are living abroad and keeping the house closed, then the day gates locked, then you have to be careful about that, right? Then next one, so the electric meter I told you it's a property of the electricity board, right? It's a property of the electricity board, and this overload circuit breaker also you have to pay for that. You can't do any repairs. Electricians cannot do any repairs or any changes in this one. That you cannot touch this. Otherwise, the people will change the reading and right. So that is illegal, right? Okay. So then next page. Okay, I'll erase this. Anyone still copying down this? Did you all finish copying down this? Right. Done, right, everyone? Okay. Let's move on to the next. Now remember these hardest lessons, I'll try my best to explain everything right from the beginning. Therefore don't miss any of the lessons, upcoming lessons, because actually it's hard and therefore I will explain in detail. I'll take time and do it because so that everyone will understand, but otherwise you can't do this again. So I don't think you most of the government semi-government schools, the teachers are on strike now, then I don't think they'll have enough time to discuss. Right. The next page, page number 2, top. Now it's easy to understand. So this is what I told, supply cable consists of two wires, live wire and the neutral wire. So if you only can put an arrow towards this red one, right, live wire, that means it's dangerous. If you touch the live wire, finish. And if you take the neutral wire, that also if you are grounded, then that will be a problem. Otherwise, no doubt. Like I'll come to this under safety later. Live and neutral, that is supply cable. So this supply cable first pass through what? Through the overload circuit breaker. Overload circuit breaker. But this overload circuit breaker, you can see it's a automatic one, not like the manual one. Capital A, right? I have already given what is overload circuit breaker. Complete the blanks here. What is overload circuit breaker? Capital A. Capital A. What is the other term used for this within bracket, right? This is also known as service fuse. So that is also called service fuse. Overload circuit breaker is capital A. Then next one, what is isolator? So you can see here isolator this entire thing is called consumer unit. This entire thing is known as consumer unit. Inside the consumer unit, there are three important components. BCD. BCD consists of this fuse box. So that's mostly this is inside your house. Isolator. What is the other term used for the isolator, right? This is called service fuse or the fuse wire or fuse wire. And this is isolator is also called main switch, that is capital B here, capital B. Even not only boys, even the girls in the house, even your mother, sisters, everyone should know this, where it is. Otherwise what happen, if your father or brothers or the elder brother, younger brother, if they are not at home and at night or until they come home, then you have to stay in the dark if the trip goes off, because you don't know where's the trip even. So just to put the lever up. So you don't take that serious. Then you light up the oil lamp and different so a lot of issues, just to put the lever up. So if the trip go off again, you have to do it manually. It goes off automatically off, but you have to on it manually. The trip, I mean trip means RCC with the next one, right? So what is the other term used for the isolator? Isolator is also known as main switch. Main switch. Next one, RCCB. What is RCCB? The trip switch, that is C here. Let's see near the main one. RCCB, we call it residual current circuit breaker. Whenever there's a leakage from your house, whenever there's a leakage of electricity from your house, this goes off, disconnecting the supply completely. So within bracket, right, this is called the trip switch. And next one, MCB. What is MCB? Miniature circuit breaker. Miniature circuit breaker, that is given by D. That is given by D. So this is in the D board. Inside the D board, each MCB control one part of your house, one circuit, sub-circuit in your house. It has a definite ampere value. So those are the main components. This order you have to remember. That's what I have asked number 7. So if you change the order, that will be a problem. Before, so this has to be done by an electrician, except the electric meter and the overload circuit breaker. Everything else you have to connect. Plug points and lamp circuits, wires, or everything, that is called wiring circuit. So remember in the textbook also they have given, I mean not textbook, the teacher's guide. Right? Teacher's guide they have given in detail, because remember they prepare this your paper based on the teacher's guide, not only from the textbook, not only based on the textbook. So they have given under chapter 11. I'll show you our learning outcomes. We call them learning outcomes. Learning outcomes. So this one, heat changes. After heat changes you get electricity lesson. This one, investigate different physics. You get competency levels. Can you see learning outcomes? Learning outcomes, very important. So in single we call it iganum pala. Your paper is prepared based on the learning outcomes. Right, so this is the one. You can see the teacher's instruction manual, competency level 3.5. You look at the other side, name the, here, this is what they ask. This is what they could ask in the exam. So this is the teacher's guide, teacher's instruction manual. So name the components in the house wiring circuit, explain the connections and actions of those, explain the safety precautions of house wiring circuit, kilowatt hours. I repeated it, all these kilowatt hours important, kilowatt hours as the unit of electrical energy. Instead, electricity supplied to the house measured in kilowatt hours, kWh, K simple, W capital, H simple. Very important. So my advice, if you are studying like, don't pay, not only the textbook, you have to refer this teacher's instruction manual also. Some subjects you are not going tuition, and sometimes you must be studying alone from the textbook, because there are some errors in the textbook also. There are some of the diagrams. So what is called learning outcomes. So this lesson only 5 periods. Learning outcomes, very very important. So that means at the end of the lesson you should be able to do this. You should be able to explain this. You should be able to compare power rating. You should be able to solve. Your O-level paper is set prepared based on these learning outcomes. So now we are discussing this part, this last part, this part. Today we are going to discuss this part. The first part I'll discuss next week. Right? Name the components of the house wiring circuit, connections, and then safety precautions and energy consumption. Right? Definitely every other from these. Otherwise, when you study the textbook, you don't know which part you will be getting. You'll be getting questions definitely from these learning outcomes. Who should be able to do this? Who should be able to explain? Who should be able to explain safety precautions? The student should be able. Learning outcomes not from the teacher. Learning outcomes are that is for the students. So this is how the teacher should teach this. Instruction for the lesson plan, that is for the teachers. Okay. So therefore you can download this from the National Institute of Education website, ni.lk. Don't need to buy these days. You can't buy these things from the bookshops. You can't go to the Mahargama NIE. You can buy this, but it's not expensive at all. This is maybe 200 or 300 rupees. But if you go to this website, www, look at this, Department of Science and Agriculture, National Institute of Education Sri Lanka, www.ni.lk. You can download English medium, Tamil medium, Sinhala medium, any teacher's guide teaching. So English medium science teacher's guide, science anyway, I'm no need to look at this, because anyway I'm doing that with you based on this learning outcomes. So I am talking about the other subject. If you are not going for tuition some subject, then you have to, I strongly recommend this. Please read the learning outcomes of the lesson before you study the textbook. Then you know what to study. Right? Understand? Right. Okay. Then back to the next one. Then number 7, the order. Okay, you can tell me the order. I use this in the PowerPoint slide also. I'll give 2 minutes. Can you quickly complete this? Starting from, I'll give the starting one. What is this? Connecting components. First you have to use overload circuit breaker. Overload circuit breaker. Can you complete the rest without my help? Complete the rest. Overload circuit breaker. Please complete in 2 minutes. Because I explained the PowerPoint slide also, now you should be able to do this. Right. Who can tell me the next component? Please raise the hand. Those are done. Please raise the hand. Those are completed this. Yes. What is the next component? What is you have to write this in the correct order. After overload circuit breaker, what should come next? Tarushi, yes. Yes, Tarushi.
Electric meter.
Electric meter, yes, correct. Electric meter. After electric meter, who can tell the next one? Devish?
Isolator.
Very good. After electric meter, you need the isolator. Yes, very good. Isolator. After isolator, what should come next? Asindu?
Trip switch.
Yeah, trip switch. So it's better to write RCCB, trip also correct, because that is the standard technical term we use. Technical term RCCB, you may write within bracket trip switch, no problem. That also will be accepted in the exam. So even isolator you can write within bracket main switch. Main switch. So don't, now whatever you do within these 2 hours, fully occupy for this. Don't engage with any other work while moving, checking the other stuff in your device. If you are doing this, it's in vain. You are wasting your parents' money and they are, I mean your time also. In therefore, fully concentrate on this. Then no need to spend more time on this again. So this will nicely, because I use the PowerPoint and textbook and learning outcomes and everything I told you. Then you will not need to study this again. You don't need to study this directly. You can put this into your head. Right? You can answer the questions. Right? What is the RCCB after that? What should come next? What is the next component? Yes. After RCCB, yes. Tasula.
MCB.
Yeah, MCB. Very good. MCB. Or else if you write distribution box also accepted, but MCB is better. Yeah, MCB. After MCB, you get what? Sockets and lamps. Sockets and lamps. Sockets means plug points. Sockets and lamp circuits. Right. Then you get then that is for the consumers, right? So before you connect any lamps or before you connect any the mobile phone charger or laptop charger to the plug point, these things should be there. You can't directly connect without these devices, components of the domestic circuit. You can't directly connect lamps or the bulbs or whatever in your house directly to the wires. That is very, actually all these for what? For the safety. All these for the safety, except electric meter, all this for the security purposes, for your safety. So there are different brands of this the devices you can buy. This is lifetime. Sometimes this is maybe for 10 to 20 years. You have to use this. You can't replace like lamps. You are not going to replace them again and again, right? Annually or monthly, you can't replace this MCB or RCCB. Therefore, they are a bit expensive. That is lifetime, right? Then number 8. Now we are going to discuss one by one. Did everyone finish copying down this? We are going to discuss one by one all these components, the main function now, because that's what they have given in the teacher's guide also. Main functions of the components of the domestic circuit. I told you there are 2 types. Modern houses, they use overload circuit breaker. Okay, please write number 8 first one. Overload circuit breaker. Right. Number 2, service fuse. Both this the same function. Let's see how it works. So I have given here modern houses and old houses, right? So modern houses, that means modern means like new, I mean about maybe your grandparents' house, maybe about 20-30 years back. So those houses, they must be having this service fuse. Actually both these the same function. So this domestic fuse allows to pass maximum of current about 30 amperes. What is the maximum current? About it's 30 amperes. If the current exceeds more than that, if if current exceeds more than that, then what happens? It disconnects the supply automatically if it is overload circuit breaker. But if it is service fuse, the fuse wire will melt. I'll repeat it again. If it is overload circuit breaker, if current exceeds than this maximum value permitted, what happened? This will automatically get open. Open means what? This is also very important. Most of the switches in your house, when the lever is up, it is on. Sorry, it's down. When you put the normal the lamps, the switches, when you put it down, it's on. Right? It's on. It's on. When you put it up, then it's off. Normal lamps, I am telling, though normal maybe the fan lamps of your house room, it's off, up. But this one the other way around. This is opposite. This is down, off. When you put the lever down, that lever down means off. If you put the lever up, it is on. This is the lever, black colored one. So you can manually do it. You can manually on and off it. Actually, automatically this will go off. This will go down automatically. Then manually you have to on it. Therefore, overload circuit breaker means before the electric meter, you have to connect this. If the load go beyond the limit means what? Normal single phase supply, that is 30 amperes current. If the current become more than 30 amperes from the national grid, from the high tension wire, the power line, supply wire, then this go off automatically, disconnecting the supply. So live wire is passed through the lower load circuit breaker. So if larger current passes through it, it disconnects power to the house. So underline larger current. Larger means more than 30 amperes. If you can highlight that. If the current become more than that, this will disconnect the supply. Otherwise, what happen? Everything get burned, right? All the refrigerator, blender, grinder, whatever operated that time, television get burned. Then power can be reconnected. How to reconnect it? This happens if larger current is it disconnect the powerhouse. It disconnect power to the house automatically, right? This happens automatically. Automatically this happens. How? By going the lever down. Then you have to put the lever up manually. Power can be reconnected by moving the lever up manually. So how to on it? By moving the lever up manually. It goes off automatically if the current exceeds than the maximum value. Then the old houses, the similar one, the same function, but this is you have to complete the name, overload circuit breaker. Actually, not only for your O-level exam, this is important for your common sense, because after some time O-level science, you might not do A-level physical science or bioscience, you might do arts, commerce and the other subjects IT. So then you might not learn this again. So not only for the exam, this is for common sense. Like everyone is using this daily. You are at night, you go to the bed, you keep the switch off. Again, if you get up early morning, you switch on. So you charge your devices on and off. So mostly it's a part of your life now, right? So eating food and drinking water. Every day you deal, everyone in the house dealing with electricity now. So I don't think anyone is staying the whole day without touching the plug point. I mean the switch or the lamp, the switch, any one of this. Definitely operate them. Then you should know how small defect you can detect it. So overload circuit breaker. For that, you have to recall the electrician to on it. Again, you don't know what to do, so you have to pay and get an electrician for that. So this pandemic situation, those things very difficult. That's why you should know something about everything. You don't need to become expert in all the areas, but you should know something about everything. Otherwise, you will be trouble in beyond 21st century. You will not be able to survive, right? Even in private or public sector, right? So what is this service fuse? Then what is this is called service fuse? What is the meaning of fuse? Fused. Can you remember ionic compound fused? In the chapter 9 heat lesson I told fusion, latent heat of fusion. What is fusion? Solid turns into liquid. What is the fuse? Fused NaCl. That means molten NaCl. In grade 10 blast furnace, molten iron, fused or slag. So that is fused means liquid. That means solid turns into liquid. there's a thin fuse wire. This thin, when the current become more than, imagine current become more than 30 amperes, when high current passes through this wire inside this tube, wire will melt. So that is the melted wire. If you only can put an arrow towards the last one, right? Melted wire, melted. So that is thin wire. So this is the thin fuse wire inside. Thin fuse wire. This thin fuse wire will melt if the current go beyond the limit. If current exceeds than the maximum value, this wire melt, disconnect in the supply. This thin fuse wire is made of alloy called tin and lead. I'll write in word first. Tin. Tin is Sn plus lead Pb. Lead is Pb. What is the symbol of lead? Pb. P capital, B simple, lead. So these are the two metals used to make this alloy. So what is the name of this alloy called? Sold. Wait. This is the next one we have right. Alloy, the name is sold. Name of the alloy will be sold. And it consists of two metals consisting tin and lead. It consists of tin and lead. Tin Sn and lead is Pb. Tin is Sn. Tin is Sn. And lead is Pb. Lead. L-E-A-D, lead. Lead is Pb. Not PD. PD is palladium. Be careful when you write the symbols of elements. Symbols of element, be careful. If you write Pb lead, Pb lead, Pd palladium. Pb lead, lead is Em, Pd palladium. So it looks same. Be careful when you write the atomic number, mass number, configuration. They don't ask these elements or the metals, but you should know the symbol. It is an alloy. Can you remember the grade 11 mixtures lesson? This is what type of mixture? Solid, homogeneous. This process of in welding shops, they use this soldering of metals. Soldering of metal, welding shops, they use this. For welding metals, they use this sold because it has low melting point. Since it has low melting point, this wire is made of lead solder. If you want to write even below this, it is made of solder. This wire, it has a low melting point. When current exceeds than the maximum value, it will melt, disconnect in the supply. Then what the problem? Not like in the overload circuit breaker, you have to get the service of the electrician and you have to replace that wire again. So it will take maybe 1 or 2 days. So when current exceeds the limit, it heats up and melt and disconnect the supply. Please write below this, put a stand right. Solder has low melting point. Please put a stand right at the bottom. Solder has low melting point. Solder has low melting point. Otherwise it will not melt even current exceeds. Then you have to manually replace this. Manually you have to replace this. Low melting point. Low melting point. Very important. Understood? Okay, so next page. Shall I erase this? Did you all finish copy now? So both these the same function. Disconnect the supply when current exceeds the maximum value. Okay. Any questions? That's all you are still copying down. Okay. Now remember, now today is the last class for this month. Nearly most of the students, those who have not excused or those who have not upgraded the name code or not joined the class program, so they will not be admitted. This one, the answer is what? By reconnecting, by moving the lever up, lever up, yeah, lever up. Then we'll complete this and we'll stop. Right, number 2, next page, top, page number 3, top, right, electric meter, electricity meter, electric meter. So what is the role? Used to measure, please write the equation also used to calculate the electricity bill. Electric meter, electric meter, unit of electrical energy, right, kWh, within bracket, right, kilowatt hours, kilowatt hour. watt divided by 1000 into number of hours. Please remember this equation. This equation is used to calculate the number of electrical units. Number of units equal watt value of the appliance divided by 1000 into number of hours. Or that is how you may calculate the electricity consumption, electrical energy. So they have given that in the resource book also. Sometimes they will ask you to calculate the number of electrical units. Sometimes they might ask you to calculate electricity unit of electrical energy. Unit of electrical energy. That means electricity supplied to the house measured using this units of electrical energy. Unit of electrical energy, number of units. So sometimes they will ask in the question paper, they will ask to calculate number of units of electrical energy. Electrical energy. Please write near this. It is a property of the electricity board. Property of electricity board. Property of electricity board. That means you can't buy this from outside from the electrical shops, electricity board or the electricity company or service provider. It is a property of the, imagine now your SIM card of your mobile phone, that is the property of the service provider. So you can't resell that to someone else, the SIM card, without transferring the ownership. So otherwise that is illegal. If someone is if that person is engaging with some criminal work, you are responsible for that. You can't tell identity, so then you also responsible. You can't. So that's a property of the SIM card, is a property of service provider. What is the use of this? If you want, you can write here, used to calculate the electricity consumption of the house wiring circuit, or used to calculate the amount of electricity consumed. Used to calculate electricity consumption in the house. What is the role of this? Used to calculate the electricity consumption in the house. So this is also, you can highlight this kWh, kilowatt hours. Now this nowadays they use digital one, digital meter. This is manual one. There's a plate, there's a disc here. This disc rotate. When if you can check the manual one, if you have in your house, this disc rotate. When you on all the lamps at night, this rotate. The disc rotate very fast. There's a disc here. Right? But now new ones, the digital meter remotely, like it's like a remote connection. They can monitor without, they don't visit your house to calculate the electricity bill. Pandemic situation, they can monitor your the reading, right? So they have that remote sensors. So then they can they will send the printed bill. They will post, or they will manually, they will by hand they will give it the bill at the end of the month. But they will not come to read the inside your house to read the reading. Okay, so that is if you install solar panels, that is they will mostly use that one, solar panels. Right. Then I'll stop here today. So it's already 10 o'clock. Please try to join on time, both paper class and theory class. Those who are joining very late, I will not admit hereafter, because you have to be punctual. Join on time, 8 o'clock, both paper class and theory class, not 8:05, not 8:10. Because I'll start the class sharp at 8 o'clock. All those are staying in the waiting room with the correct name code, I'll admit. Otherwise, if you're not joining with the correct name code and joining late, so you have to be, that discipline is very, very important. Right. So then tomorrow night, the Saturday night paper class will be doing support in a papers discussion, and I'll post one more paper. So I'll stop for today. Not hard. You will not forget it easily, because I use my maxim. So there's a video clip also I'll try to show at the end of the lesson. These lessons upcoming lessons are a bit hard, therefore I'll take time and do it. Otherwise no point of just covering the syllabus without understanding the concept, right? Okay, then good night everyone, and God bless you all. We'll stop for today, and rest will continue next day.